Hi everyone, my name is Dr. Solush and today we are going to start with linear regression. So in this video, we will start with the theory part first and then we will be having a hands-on in Python code. So we use linear regression to see the association of input features with the target feature. So looking at the definition, linear regression is a statistical method to predict a value based on a given set of data. It assumes that there is a linear relationship between the independent and the dependent variable. So if we take example of house pricing data and based on number of rooms, where we have the house price is Y and the target feature and X, that is the number of rooms. So in case we have 0 rooms in the house, so definitely the price would be less. But in case we have 4 rooms in the house, then the price would be definitely more for that kind of house. So the main purpose of linear regression is that we want to use the model that gives us the best line to get the house prediction. This is the main purpose of the linear regression. We can write mathematically linear regression equation as y equals mx plus b. So m is the slope that tells us that 1 unit change in x, it is going to impact how much increase in y price. However, the intercept is the constant value. Simply, I can define that one is just like if we have the house price, if we say that is Y feature, and based on number of rooms. So, in case in the house there is no room, then definitely it is a land. The price might be 50K, right? So, if we have 50K price with no room, but if we have one room added to that one, so definitely the price could increase. So here, when we have this is the constant value without any room, but in case it is going to increase the one room, then the price is definitely might be it is going to be 80K or more. So this is the example of the equation that it says that with the intercept price, we have a constant price and but 1 unit change in X, how much increase in Y it would be, or if we have 2 rooms, so definitely that price would be more. So this is called a slope. The main goal of the linear equation here comes that we are going to see the best M and B to get the best line fit. Then we are going to have assumptions of the linear regression. When we are training a model, then we have to see that first assumption is that linearity should be in the relationship. That means x and y should be having a straight line. The second assumption is that no multicollinearity. That means that if the data set has multiple independent features, they shouldn't be correlated with each other. Otherwise, it is going to create the noise in the model. So to check this one, we can use the correlation matrix or we can use VIF that we are going to use into Python code as well. Third assumption is homoscedasticity, that is, the error should be constant, it shouldn't be spread over. So if it is showing us no constant values of errors, then this is a third violation of the assumptions. And fourth one is the normality of errors, that the difference between the actual and the predicted values, it should be showing the normality. Fifth assumption is that independence of errors, that there shouldn't be any autocorrelation. So mostly we see that one in the time series problems using the ACF and the PACF plot. So this is all about the theory part. So now we will be moving forward to the code. And for that one, we are going to use the student performance data. And here the main purpose is that we want to predict the maths score of the students. So starting with the first step comes that we need to import the libraries for the reading and training the model. After importing, then we have to read the data set. So here we have CSV file and we can read the first 5 lines of the data. So here we can see the target feature and the three features are kind of integer. And in case we want to see the shape of the data, we have 1,000 rows and 8 columns. We can see the rows using 0. And if we want to see the number of columns, then we can use the shape 1. And if we want to see the names of the columns, so we can get using columns. In case we want to see the information that how many rows in each column and how many object and the integer features are there. So we can use this command to get the information about the feature. And in exploratory part, we can see that either there is kind of a missing value in the data. In our data, there are no missing values. And in case we want to see the how the distribution of the column looks like, it's kind of a central measures of central tendency. And we want to see that how much min and max and the mean value of each integer column looks like, then we can see using the describe function. Then comes that in case I want to see the distribution of the target feature, that's a math score using KD plot. Um, and in this chart, the distribution looks like positively skewed. And then we can go with the pair plot to see the linear relationship of or how the distribution looks like. So here we are using only 3 columns. These are the integer column, math score, reading score, and writing score. So looking at the math score, that's a target feature. We see writing score and the reading score both are linearly related, but however the distribution looks almost the same. So here the point comes that there is kind of multicollinearity in the data, but let's check further. So first I'm taking the reading score with the math score, looking at the Seaborn library and getting the scatter plot. So it's the same visual as we saw here. So it's almost the same, only we are taking one feature and looking at the target feature. Then the second assumption is the checking the multicollinearity. So first I'm doing the correlation metric. So here we can see with the math score. So reading and writing both have zero point 0.8. It's a kind of highly correlated with that one. So it seems like this is one indication that there is a multicollinearity. And when we read the correlation matrix, so always we have kind of diagonal shape. So we can take this part or that part because it's kind of a repetition. This is for just a reading correlation matrix table. Again, since we observe that high correlation, then we are going to check the multicollinearity using the variance inflation factor. So here again, this is the second kind of evidence that the both features have almost more than 10 VIF. So when we have this kind of a situation, then we have to drop or combine the both features. So, but looking at for this demo, I am just taking the reading score, I'm dropping the writing score, and I will be training model based on the reading score. So after doing that, once since we know that how the shape looks like, then we can split the data and taking the X feature from the our data frame and target feature is a math score. I'm going to split the data into 80 and 20 ratio. I will be keeping 80 for training data and 20 for testing the data. After running this one, we are ready to train the model. I'm using the linear regression. And from scikit-learn, importing the linear regression library, I'm fitting the data to the model and predicting getting the prediction based on the x-text, that is out of sample that we kept for just like 20%. Once we have that one, we can get the coefficient and the intercept of this model. So this is kind of value we are getting after the prediction test and prediction shape. So we have 200. And once we have that one, we can just see the error rate, that how our model is behaving as compared to the actual value, that is y-test. So MAE and MSE, these are going to help us. That is going to tell us that how our model looks like. Minimum error is the best. So, and this is kind of the shape of y-test and the y-predict in the scatter plot. We are done with this kind of evaluation and testing. Now, in case we want to check the third assumption, that is homoscedasticity, that either uh, the residual, it is showing us a normal distribution or not. So this is how it is showing if you see the center of line and how it is distributed. So this is the last check of the assumptions. So once we are done with that one, we can simply save our model in a pickle file, importing pickle and saving as a pickle file. And we can just give to the machine learning engineer for deploying that model, or we can deploy this model that we can see later on when we are doing the deployment. So this is all about the linear regression. I hope this helps, and you can use this code from my GitHub. Thank you.